Welcome back to the formulaic approach. Now let's talk about the Saytzeff's rule or Zaitzev's rule. Okay, now the rule is it follows the process of synthesizing alkene by the removal of hydrogen halide from an alkyl halide. Okay, now we call it dehydrohalogenation. The process is called dehydrohalogenation of alkyl halide. All right. So what we want to remove is an halogen. D means out, to remove, okay, or not. All right. Then hydro means hydrogen. Then halogen refers to the fluorine, chlorine, bromine, iodine, etc., astatine. So these guys. So we want to remove hydrogen and what? And halogen. Okay. So now, when we want to remove hydrogen and halogen from an alkyl halide, the R here represents an alkyl group, X here represents halide, halogen group. Now, whenever you want to remove it, the Zaitzev rule says that you should remove the double bond that you want to form, because you want to form an alkene here. The double bond that you should be formed between a carbon that is higher in power. Think of it that way. That is higher in power, and between two carbons that are higher in power. Not to remove from carbons that are lower in power. Yeah, I'm going to explain that. Just calm down. Now, what I mean by higher in power is this. Now, we define carbons with respect, we name carbons with respect to their positions. So the carbon we are particular about is, for example, going to be called the alpha carbon. Okay. Now, the alpha carbon there can be in three possible positions, either be in the primary, be a primary carbon, or a secondary carbon, or a tertiary carbon. So a tertiary carbon is in the senior position. Secondary is in the, just think of it as tertiary institution, secondary school, and primary school. Okay, so tertiary institution is higher than secondary school. Does that make sense? So using the Saytzeff rule, the double bond you want to form your alkene is going to form most likely between a tertiary carbon. It will be formed with a tertiary carbon than a secondary carbon before you consider a primary carbon, if at all you consider a primary carbon. Does that make sense? So what that means is that where there is an option to choose between secondary or tertiary carbon, you should choose tertiary. Where there's an option to choose between primary and secondary, you choose secondary. Does that make sense? Now let me put this in equation so that you will understand well. So for example, if I have this guy now, I put my Br here, so CH3, no, CH2, CH3. Now look at this guy now. We want to dehydrohalogenate. Now keep in mind also that this process takes place in a basic medium. We use an alcoholic base, okay? So a base that is in an alcohol. So that's what we call it, alcoholic base. So this guy, want to dehydrohalogenate this guy. What does that mean? It means we want to remove what? Hydrogen bromide from here. Okay, this acid, we want to remove it from here. Now, what does the Zaitzev rule say? There are two possible answers we can get from here. The first one is that we'll get, the first one that is possible is we get CH2 double bond CH, then CH2, CH3. This is the first. The second is CH3, CH, double bond CH, CH3. Okay, now notice that I don't know if I have to express this in, okay, let me show you in the full chain, okay, let me show you in the full chain so that you will understand better. So watch me. See, so the first product I said is either we have CH2 like this, CH2, then our double bond will be here. So we have CH, and then we have CH2, and then we have CH3. Or we have another product, or this. And this actually, because it's going to be a mixture of products. But we are trying to determine which one will be the major product, okay? The one that will be formed the most in more than 80% of the case. So we have CH3 bonded to CH, which is now double bonded to CH again. Now this one can also be up because the conformation for this one does not really matter because there is no steric hindrance. You can put CH there, okay, but I decided to just put it this way. This is called anti-periplanar position, okay? Now listen, you see that this guy, there are two possible products, either will form this or this. Now what does Zaitzev say? Zaitzev says that it is this that will be the major product. Now why? The reason is because this double bond here, the double bond here is formed between a primary carbon and a secondary carbon. But the double bond here is formed between a secondary carbon and another secondary carbon. Then if you are confused to how I knew that it is primary or secondary carbon, when a particular carbon that is in question is connected to one more carbon, then it will be secondary. When it is connected, if it is connected to two carbons rather, first, if it is connected to one carbon, this is primary, this is primary. Does that make sense? If this carbon that is in question here is connected to two other carbons, that is, this is connected to this guy, then connected to another carbon behind it, then this guy here will be what? Secondary. This one here, this terminal one here will be primary. Does that make sense? If I now connect this same carbon to another, maybe CH3, alkyl group here, this carbon here has become senior man. Has become what? Senior man. What do I mean by that? Tertiary. Why is it tertiary? Because it's connected to three other carbons. Does that make sense? Now what that means is that since it is connected to these more guys, it means it has more electron density. Think of it that way, okay? We call those groups around it, we call them electron donating groups. I'll teach you when we get to mechanism of reaction, I'll still talk about it. I'm only bringing this out because someone asked a question. So now you see, they are electron donating group. So because of that, this carbon here is going to enjoy a lot of electron density, electron availability. Do you understand? Than this carbon here. This carbon here is primary. This one here is primary. This one here is primary. Because why? Why? Because they are connected to one carbon each, except this central carbon here that is connected to three other carbons. So this bond here, so you now know what we mean by primary, secondary, and tertiary, right? So this carbon here is connected to one carbon, right? So this is primary. This carbon here is connected to two carbons, so this is secondary. Now the bond is formed between a primary and a secondary. But look here, the bond here is formed between this carbon and this carbon, which are both secondary. So because of that, they are what? Higher than this guy. So this will be the major product, while this guy above here will be the minor product. Okay? I'm going to tell you the reason why it is so. But let me test you with one more example. Now look at this one. What if it were something like this? Okay, so we have this molecule here now. This will be 1, 2, this will be 1, 2, 3, 1, 2, 3, 4, 1, 2. So this will be 2 methyl, 3 bromo, 1, 2, 3, 4, 5, pentane. 2 methyl, 3 bromopentane. Now we want to dehydrohalogenate, that is, we want to remove HBr from it, okay? Using alcoholic KOH, right? All right. Now, what are the possible products that we can form? Let me write the two possible products here. Now, you will now tell me which one will be the major product. All right. So, is either we form this, is either we form this or we form this. This is the second possible product. So these are our two possible products. Is that we form this guy or this guy. Now we'll name it afterwards. So which one do you think is going to be our major product, A or B? Now the answer is going to be what? A. Yes, A will be our major product. Why? This guy, Zaitzev says that you should form between the carbon that is most substituted. The way it is written is that when you want to form alkene from an alkyl halide, the most substituted carbon will be the major product. Now wait until the end of this video because I'm going to show you a negation to his rule. Okay, I'm going to show you what we call the Hofmann's rule. So, but his rule says that we should form with the most substituted carbon, right? Which one is most substituted here? Look here. If you form the bond between this carbon and this carbon, what kind of carbon is this? This carbon is connected to 1, 2, 3, tertiary. This carbon is connected to 1, 2, secondary. Let's come here. This carbon here, that the bond is between these two, right? This carbon here is connected to 1, 2, so this guy is secondary. This one is connected to 1, 2, so this one is also secondary. Now, as it is, which one wins? Is it the one that is tertiary and secondary or secondary? This one wins, right? Because it's most substituted. Do you understand? All right. So before I now tell you the negation to the rule, why is this the case? This is true or this is the case because usually in the reaction mechanism, there needs to be the formation of, they sometimes occur the formation of a carbocation. Okay, a carbocation or carbonium ion. Okay, all right. A carbocation is a carbon that is carrying a positive charge. A carbocation is a carbon that is carrying what? A positive charge. Now, when we have a carbocation, a carbocation is stabilized by the degree of substitution that it has. So what that means is that the more groups attached, the more bulky group attached to our carbon that is bearing positive charge, the more it is stable. Does that make sense to you? The more group attached, the more it is what? Stable. All right. So now let me give you the series of the types that we have. So if we have a methyl group carbocation cannot even form. Does that make sense? A methyl group carbocation cannot form. Now, if you now have now this is methyl. Now we now have a carbocation that is formed from a secondary. A primary rather. So this is a primary carbocation. Okay. This one is more stable than this one. So this one is less stable than this, while this one is less stable than a secondary carbocation. Does that make sense? While this one is less stable than a tertiary carbocation. So you see that the degree of substitution helps in the stabilization of this guy. And how does it help? It helps in the stabilization through what is called hyperconjugation effect. It's just big grammar. What that means is that those groups they are electron donating groups. Why? Because electron is plenty in them. So because of that, they make electron available for this. When you have a positive sign, it means what? Electron deficient, right? So this is an electron deficient center. So the more group that are around it will donate electron. They will not make this carbon to fill the lack of this electron deficiency. Does that make sense? Good. Now let's now go to the negation to his rule. Now what is the negation to his rule? The negation to his rule is now called the Hofmann's rule. The Hofmann's rule. Now what does the Hofmann rule say? The Hofmann's rule now said that this is true, but in a case where there is a heavy or bulky group. That is, Hofmann rule is saying that when we want to dehydrogenate an alkyl halide in the presence of a bulky base, the reverse anti-Zaitzev's product. Anti-Zaitzev's product is formed. Okay, so let's go back here now. Let me give you an example of a bulky base. Let's say we have the tert butoxide here, for example, potassium tert butoxide, or potassium or just tert butoxide with a minus here. Now with this guy here, if we want to now remove H and Br because of the bulkiness of this group, because of the bulkiness, it will not be able to approach a carbon that has many groups too around it. It will be hard for it to approach. So what it will do is that it will abstract the hydrogen from the nearest or the easiest to reach carbon. Does that make sense to you? I'm going to reiterate. I said this bulky group, because it is bulky, it has plenty load that's already carrying. That is, it has to many groups. Now, because of that, instead of go to the most substituted carbon, that is the carbon that has many more carbons around it, it will not. It will rather go to another carbon that has less group around it, with which it can easily get, or from which it can easily get hydrogen, and then take the hydrogen. So in that case, in the presence of tert butoxide, this will not be our answer. This will be our answer. This guy is going to be our answer because this is the easiest to reach carbon. This carbon is easier to reach for, you know that Br is on this. So is either it wants to, it will choose to collect this hydrogen or this hydrogen. So what it will do is that it will come to this one. This because this carbon is easier to reach than this one. This one has 3 more groups around it. So because of its bulkiness, it cannot come here. It will come here rather, or here. And then it will abstract hydrogen. So this will be our Hofmann's product. This will be our what? Hofmann's product. Alright. So this will be it for this video. Do what to subscribe to the channel and click the notification bell to get notified whenever I drop a new video. Thank you and God bless you.